cubed plus 31x squared plus 49x plus 30. So on this one, I need to make my list of possible rational zeros, which means I'm going to take the factors of 30 and divide them by the factors of my leading coefficient, which is 1. The good news is anytime I divide by 1, it's just that number. So I don't actually have to do any division there. So what are my factors of 30? So 1, 2, 3, 5, 6, 10, 15, and 30. Say that again.
I just said, how do you find them?
So I just think about, okay, what do I multiply together to get to 30? 1 and 30, 2 and 15, 3, 10, 5, and 6. Yep. Once I've made that list, I need to go ahead and test using synthetic division to see if I can find any of my zeros. Of course, I'm going to tell you which ones we're going to test on this one to save some time. How many times will I need to do synthetic division on this?
2.
Twice to get it down to a quadratic that I can then use the quadratic formula to solve. I need to get it down to a quadratic, and then I can stop with the synthetic division. So for synthetic division, I'm going to, of course, set up my table. And I think we're just going to, I don't know, guess, and we'll divide out -2.
Wait, where are you getting? Oh, never mind.
So when we divide out -2, the 1 drops straight down. 1 times -2 is -2. 9 minus 2 is 7. 7 and -2 is -14. And I just keep doing this. And what do you know? I get a remainder of 0, which means it is a factor. So I can go ahead and circle it because it's also a 0. And I write out what I have left, which is x cubed plus 7x squared plus 17x plus 15. I'm going to use this new quotient to set up a new synthetic division chart. And I'm going to pull another number from my list and test it and see if it works. So when I set up my new synthetic division chart, I have 1, 7, 17, 15. And then, oh, I don't know. I think we're just going to take a stab in the dark and divide out -3.
I love how you say that as if you don't know.
So we're
Right,
just
that
like
doesn't matter.
doing that thing where you pull out the factors and see which ones work.
Yep. Chances are you're going to find more that don't work than do work, and that's okay. So we drop the 1 straight down. 1 and -3 is -3. I just keep doing this until I find out whether it's a remainder of 0 or not. This one is. So the quadratic that I have left, I will then use the quadratic formula to solve out, and those will be my 2 remaining zeros. So I have x squared plus 4x plus 5. You can go ahead and do the quadratic formula. When you do, you get x equals -2 plus or minus I. You guys can go ahead and work through that one on your own. What do I do once I've identified all of my zeros?
You put them in your curly brackets
We put them in our curly brackets. How do I know that I'm done here?
because you have 4 zeros.
And how did I know I only needed 4 zeros, Noah?
Because your leading exponent was 4.
Correct. So the degree of my polynomial was 4, which meant that I had 4 zeros in total. Any questions on that? You can almost guarantee there's going to be one like this on tomorrow's test.
Wait, so you knew it was -2?
That wasn't like,
Yes.
horrible.
So you just have to guess?
You just got to pick them and guess.
So it's like the ones that equal 0 is going to be the
Yes. Yes, ma'am.
There was something before that if you guessed one of them and it wasn't it, there's one that is like it was greater than that, that's not it as well.
Okay, so that was like upper and lower bounds. I do not want to get into that just because it's going to make things a little more confusing. but I'm more than happy to explain that to you individually if it's something you're interested in. I just don't want to throw that on you last minute.
So that's not what this is?
No.
Oh.
It doesn't really help, no. Not in this sense, not with a time crunch like this.
And we're not gonna need it.
No. Yes, ma'am.
Okay, so how can we solve out that one? Like, come up with
This one, because I don't have a formula for cubic equation. I had a formula for quadratic. I could have done synthetic division somewhere, but there's no guarantee that it's gonna give me two real answers, and it came out that it didn't. So it would have been a waste of time. So why not, when we get it to a quadratic, do a way that guarantees an answer? Yeah, so that's just a shortcut, saves on time.
Okay, so when you can do a quadratic formula.
You absolutely should, yep. Okay, so number 17, also something you can guess is probably gonna be on the final exam in some way, shape, or form. And it says, given this function, I know Cort's favorite word right there. It would like for me to identify any and all of my asymptotes, any hole that I have, and then the intercepts as well.
I feel like you definitely.
Hey, can I show them my pencil? really
Say that
fast?
again.
I said, I feel like you definitely put one of these.
Oh yeah, you can pretty much bet there's gonna be one of these on there in some way, shape, or form.
This is
Can I
17,
sharpen
right?
this really
Huh?
quickly?
This is
Some
17.
asymptotes and
17.
asymptotes and whole, and they're on.
Okay, so when I'm working through a rational functions problem like this, what do I look for first to identify?
Your holes.
My holes. I can only do this if it's in factored form. Guess what? We're already in factored form. So a hole exists when what is shared between the numerator and denominator?
Same thing.
A same factor or the same thing. Do I have that here?
Yeah.
Yes. At x plus 2, because they are the exact same, which means I take that x plus 2, I set it equal to 0, and I solve, and that's my removable discontinuity or hole, whatever you want to call it. So I have a removable discontinuity at x equals negative 2, because I took that x plus 2 and I set it equal to 0, and I solved. Okay, what do I look for next?
Your vertical asymptote.
My vertical asymptote. Colin, where's that going to be?
Isn't it your 4 and your 3?
Nope.
Is it the x minus 1 and x? No, it's the degrees, isn't it?
Nope.
I don't know then.
How do I identify a vertical asymptote, or how do I know that one exists?
Whatever's remaining at the bottom.
Right, because a vertical asymptote is where my function is undefined. The only way to get undefined is to divide by 0, which means a 0 has to exist in my denominator. So I take any factor that's left in my denominator, and I set it equal to 0, and that will be my vertical asymptote. So here I have a vertical at x equals 5.
Why x equal, or why is it x minus 5 again, not the top one?
Because a 0 in the denominator gives me undefined, and that's where vertical exists. A 0 in the numerator is just a 0.
I think you got, or I think you wrote this one.
I did. I put it as 2, but it should be 5.
Because I was confused. I
Yeah.
was like,
I made several mistakes. I'm about to upload a new picture as soon as I wanted to go through and make sure I didn't have any other mistakes that I missed. So, sorry. I'm terrible.
You say you call yourself a calculator?
How many you missed you add on to our thing?
How about I just curve it and it'll end up even anyway?
A curve for
Not necessarily,
Not
because
gonna play.
people might get like a 90,
Not trying to call anyone out, Tim.
and then there's other people who are gonna get Fs.
Oh, come on. Have confidence in yourselves.
No.
I have
I'm
no
feeling myself with
idea.
much confidence that I possibly could
There's
have
confidence
myself.
and then there's realistic.
There's confidence and then there's knowing my limits.
Okay, let's return, please. I have found my removable or my hole. I have found my vertical. What's next?
Horizontal.
Or
Oblique.
oblique. It can have either or. Do not forget about your oblique asymptote. How do I identify which one I have?
Is this the degree?
based off of.
The degree of my numerator versus the degree of my denominator. If the degrees are the same, I have a horizontal. If the degree of my denominator is larger, I have a horizontal. If the degree of my numerator is larger, I have an oblique, and I would use synthetic or other division to solve. Which one do I have here, horizontal or oblique?
Horizontal.
How do I know? I don't have this in standard form, so how do I identify the degree of each of these?
Because there's the same amount of X's.
The number of X's correlates to the degree. So I have 2 X's in my numerator and I have 2 X's in my denominator, which means each of these are a degree 2 polynomial. Since they are the same, I know it's horizontal. And that horizontal asymptote is going to be what over what?
4/3.
Leading coefficient over leading coefficient, which here is 4/3. So my horizontal asymptote is at y equals 4/3.
Wait, why is the vertical at 5? I must have missed it.
I had a factor left in my denominator. I set that equal to 0, and that's how I got that.
You just take the leftover factor out of the denominator.
Yeah, that's it. That's my vertical. And sometimes you'll have 2, sometimes you'll have 3, sometimes you'll have 1, sometimes you'll have none.
Always gonna be that one bottom.
Yeah, for a vertical, always. Okay, am I finished?
No,
What else did I ask for in this problem?
your intercepts.
My intercepts, which means my x-intercept or intercepts, and my y-intercept or intercepts. Okay, the easiest way to do this, my x-intercepts are any factors left in my numerator that were not a whole. So do I have anything left in my numerator?
Yeah.
Which I set equal to 0 and solve, and I get x equals 1 is an x-intercept. Which you could also write as the point 1, 0. To find my y-intercept, I go back to my original equation. I plug in 0 for all of my x's, and I solve to find my y-intercept. So if I plug 0 in for all of my x's, I'm going to get 4 times 0 plus 2 is 2. 0 minus 1 is negative 1. Or 3 times 0 plus 2 is 2. 0 minus 5 is negative 5. I simplify it. 4 times 2 is 8. Times a negative 1 is negative 8. 3 times 2 is 6. Times a negative 5 is a negative 30. And I reduce this by pulling a 2 out of each of these. And I get 4/15 is my y-intercept. You do not have to write it as y equals. You could also write it as the point 0, 4/15.
I'm sorry.
You're okay.
Is that the x-intercept and
Any factor left in my numerator, I set equal to 0. Yes. Any other questions on this one? Yes.
What do you mean by any factors left?
So after I took out my removable,
Yeah.
what did I have left in my numerator? I had x minus 1.
So you, oh,
So that's how I found my x-intercept. Yes.
Oh, never mind.
Okay. Any other questions on that one?
how did you find or know it's vertical, or how did you know the horizontal versus the oblique? How'd you know?
I looked at the degree or the number of x's present in my numerator versus my denominator. They were the same, which means it's horizontal.
And oblique has to be.
The more x's in the top than in the bottom.
okay, hold on, I'm gonna write that, so. There's more x's on top.
Or a degree of numerator is
Wait,
larger
how do
than the
you
degree
find
of the denominator.
oblique again, though?
How do we find an oblique asymptote if one occurs?
If the numerator is bigger than the.
But how do we find it? What do we use?
It's more synthetic division.
Or long division. We do division, whatever quotient I get is my oblique asymptote.
What are you plugging in for the?
And then you
Well, I would
said
do this divided by that. If
So
I
you just
had an
actually
oblique.
do it.
Numerator divided by denominator. Legit, just like that. Yes.
Since there is a hole, can it, like when you're trying to find the y-intercept, can you just leave that out and it's give you the same answer?
Yes, because it's top and bottom are going to cancel. Yeah.
Yeah.
I just prefer to always go back to the beginning because I don't want kids to get confused. But yes, it will work that way too.
Because I saw that and I was like, wait, they're the same thing.
Any other questions?
Can
How
you
did you
define,
find the
like, define the oblique if you don't know how to do the actual division thing? What work you put in the calculator?
Some calculators might, some calculators won't. I can't promise that it will. Okay, so 18 is very similar to this one, except it wants us to actually graph it. So it's putting all of this on a graph. Do we need to go over that one?
No, you just gotta put.
So it's just putting a dotted line where there's a vertical asymptote. It's putting a dotted line where there's a horizontal asymptote. It's putting in points by plugging in x values and getting y values. It's just graphing it. Yes.
So once you find your hole, do you plug it back into the equation to find the other point? Or
For a hole, for what other point?
so like for 18, there is a hole
Mhm.
and it was by 1 or whatever.
So I drew my graph first, and then I went into the x value and just drew the hole where the graph was.
And you're
I didn't do it at a specific y value.
Okay.
posting the video for.
Oh, so okay, I see what you're saying now. This is wherever it crosses by that point.
Okay, do we want to do that right now?
No.
Okay, I'm gonna tell you if you can do this, the graphing is a very small piece of that. Okay, if you can do this, this is what I'm focused on. Okay, so the next one is just a couple of definitions. I'm not going to go over those. You can look at them in the notes, or you can find them on here or in the notes or on Google, whatever you want to do. So then 20 is Descartes' rule. Find the possible number of positive, negative, and imaginary roots. So the equation that I've been given is 2x to the 4th minus 4x cubed plus 2x squared minus 5x minus 7 equals 0. I always find the positive first, which means I use the original function, and I count the number of sign changes that occur. Then I take that number and subtract 2 as many times as possible to find all of the possible positive options. So how many sign changes did I have here? Well, I had 1, 2, 3. Anybody see any that I missed?
No.
Okay, so for positives, I had 3 sign changes, which means I had 3 or 1 possible positive roots. Possible positive real roots. There we go. Any questions on how I got 3 or 1?
Where does the or 1 coming from?
I subtract 2 from 3. 3 minus 2 is 1.
Why are we subtracting?
Because Descartes' rule says if I have less roots than the number of sign changes, I differ by a multiple of 2. So we have to subtract 2 as many times as possible.
That's right.
You can never have a negative number, right?
So we always stop at 0 or 1. Yes.
Wait, by subtracting 2 as many times as possible, so if that came out to like a 2 instead of a 1, and do it again.
Yes. Was that your question too, Matt?
Wait, so why is
I
it,
don't have one.
why is it 3 over 1?
Because 3 minus 2 is 1. So now I do my negative roots. To do this, I need to plug in negative x. What is my little shortcut rule that tells me which ones change and which ones don't?
If the exponent is positive or negative. No.
If the exponent is odd, the
That's what I
term
meant.
changes sign. If the exponent is even, the term stays the same. Boys, did you hear that? If the exponent is odd, the term changes sign. If the exponent is even, the term stays the same. So 2x to the 4th, 4 is even, so that term stays 2x to the 4th. X cubed is odd, so that changes from a negative to a positive 4x cubed. This one stays the same because it's even. This one changes sign, so it becomes positive 5x. And then the minus 7 on the end just stays
Wait, why is
So
it
all of
negative?
that.
because I plugged in negative x. Any odd exponent term changes sign. Any
Oh.
even exponent term stays the same.
So why did it become? Oh, never mind.
And that makes sense.
So now I count the number of sign changes occurring here.
I never knew that.
How many sign changes did I have?
1.
So that means for negative options, I'm guaranteed to have 1 negative real root.
Okay, and so, I'm sorry,
No, you're fine.
but, so you got that, you did 3 minus 2. Did you get the 2 because there was 2 sides?
No, Descartes' rule tells me that if I have less than the number of sign changes, it differs by a multiple of 2, which means I just keep subtracting 2. That's the rule.
Okay, so yeah, it's always.
Always subtract 2. Just like I cannot subtract 2 from 1, so 1 is a guarantee. I can't have any other options. Now we set up our little table. So I have positive, I have negative, and then I will fill in with the number of imaginary zeros that are required. And each of these columns has to add up to what? 4. The degree of my polynomial is 4. So each of these has to add up to 4. I list my positive number of options, the number of times that I have negative options. So because I only have one negative option, I'm only listing these positive options once. Sometimes we have to repeat them a couple of times. This one I do not. So I have 3 or 1 possible positive rational roots. Then I only had 1 negative, so I have to put it under both of those options. And then I fill in the necessary number to make my column add up to 4. So if I have 3 positive and 1 negative, how many imaginary can I have? 0, because 3 plus 1 is already 4. If I have 1 positive and 1 negative, how many imaginary can I have?
2.
1 plus 1 is 2. I need 2 more to make it 4. And then this is it.
Can you say complex for imaginary? Because I remember this being.
Yes, imaginary and complex are kind of interchangeable here.
And so you put the 1 there because just to feel that.
Because I had 1 negative, yeah. I like to use imaginary because then you remember that your answer should get an I in it. If that helps you remember that any better. But complex means the same thing. Baker.
So if the negative ones would have been like
2 or 0, then I would have listed this option twice.
so like 3 or 1.
Or a 3 or 1. And I would have had 2 under these 2 and 0 under these 2.
Where do you think of
I see how it is.
more
I
like
didn't
for us
mean,
to
you
get
didn't mean that. No.
The degree of my
I did not
to
polynomial.
the very first one?
Yeah, the degree of the
know, like,
highest
like
exponent of
without-
the polynomials are degree.
Because I didn't mean to, even though I did call
If you were to have like, say you were to have like 4 or 5 positive changes, then would it be 3 or, so it would be 5 or 3 or 1,
5 or 3 or 1.
or 4 or 2?
Yes. You subtract as many times as possible.
This is all we do for this entire question. Like that's.
Yeah, that's all. I just want that table.
So if there's 4 sign changes, it's
4 or 2 or 0.
or 0.
I will tell you that if I gave you this problem, to save on time, I only asked you to find, I think, the number of positive and negative possible roots.
Not
Just to save on time.
Well, imagine that.
oh, that's nice.
I'm pretty sure that's what I did. I can check real quick.
But imaginary doesn't take that long.
I know, but I didn't want to overwhelm
So
you
this
guys.
one's also on the final.
Yeah, probably on the.
If
front,
I
like,
asked
to
it,
get
yes.
He's not gonna tell you whether it's on there or not.
Well, she already
Yes.
told us 2 of them are on there.
If I put it on here, I only ask for the number of positive and negative.
If we put the imaginary just to like.
That's fine. I'm not gonna catch you off. That's your choice.
The total number of them has to add up to
The highest exponent in my
So if that
polynomial.
was 6, then they would have to add.
Okay, so that was 20. 21, I said will not have a likeness on the final exam. So let's not even worry about it. I don't want to overwhelm you. 22, I'm leaving for you. I'm not helping you with that one. It's in the notes. You can find it.
Wow.
One-to-one functions.
That's pretty easy.
23 asks us to find our inverse and then to graph it, but that's not really super important. I'm really only testing about the inverse part of it.
No, I don't want to try. Take that off. It's fine. Take it off.
Take it on the blue.
You're so anti-person to
If my original function is 10 minus 15x, I need to find my inverse function. What is the first thing I want to do if I'm trying to find an inverse from an original?
Swap your y and x.
Switch my y and my x. So this becomes x equals 10 minus 15y. And now solve for y. So I'm going to subtract 10 over to the left. And then I'm going to divide by negative 15. So my inverse is x minus 10 over negative 15. when you were writing this, I prefer you write it in inverse notation, which is f negative 1 or g negative 1, depending on what our function was. Yes, Noah?
Could I put the 15 on the two separate?
Yes, you
Numbers
can
and then-
separate it into two terms if
Okay.
you'd like to.
So you don't want y, you want f negative.
I
one.
want f negative 1 is the final answer.
Is that, so that's the
If I put
inverse.
f negative 1 equals y equals
That's fine.
that, because that helps.
Yeah. When you were graphing this, these are straight lines, which means that this is my y-intercept and this is my slope. Same thing on this one. If I separate it into two terms, the number with my x is my slope. The number not with my x is my y-intercept. We can graph that. We've been doing that since middle school. I do not feel the need to go over that again with you. If you want to meet with me individually, I'm here at 6:30 tomorrow morning. Come find me. Number 24, these are pretty much just canceling or plugging into your calculator.
Let's see. Said it was one, but I just said it wasn't possible. They're the same thing.
But if they're the same thing, I still had something in the exponent on e. So we assume that was e to the 1, which means when ln and e canceled, it went to 1. Okay, but we'll come to that one. So 24a gives me log base 2 of 1 over 16 equals x, and it would like for me to solve for x. Do I need to do something super fancy and convert this around? We can, but what else could I do instead?
Your change of base.
My change of base formula. I have log, base, and a number. I can plug that into my calculator. So then this becomes log of 1 over 16 divided by log of 2, which gives me -4 as an answer. And I get that directly from my calculator. It makes sense though, because 2 to the 4th is 16. So if I make it -4, that 16 moves to the opposite side of the fraction.
That's the answer.
That's the answer, -4.
So you can just plug these into your calculator and it'll give
If
you-
I have a base that's a number and a what I'm taking the log of is a number, yes, absolutely.
Okay,
But
so
how do I make a base calculator? Because once I hit the log button.
Well, that's why we do this.
it gives me-
'cause this lets me do that. It's a way to plug it in without having to do what the calculator wants me to do.
so you changed.
I did my change of base formula, and then I just plugged it right in.
Wait, how would you plug in an equals -4?
No, this was the answer that the calculator gave me.
You know what?
This is what I put in my calculator.
I am very smart.
Okay, part B,
It's okay, Jen.
give me the log base pi of 1 equals x.
Just do the same thing.
Okay, we could just do the same thing here, or I could think logically about what this is saying as an exponential function, which says that pi to the x equals 1. What's the only exponent that I can plug in that's going to make my base go to 1?
0.
So x is going to equal 0, but you would also get that using your change of base formula. So you can think logically, or you can just use your calculator on some of these.
Log. So if you did change your base formula.
Log of 1 over log of pi.
Wait, how did you do that?
Well, you can do log of 1 over log of pi, or you can rewrite this as an exponential, which was pi to the x power equals 1. Only way to get 1 with a base that's not 1 is to take it to the 0 power. Any questions on that one?
No.
Okay, C and D are both kind of canceling with inverses. So C has the natural log of E. This is the same as natural log of E to the 1. So whenever we don't see an exponent present, we always assume it's a 1. Which means when my natural log and E cancel each other out, that 1 becomes my answer.
Oh yeah, I forgot.
You could also plug that in your calculator. You have a natural log button, you have an E button. Not that I'm encouraging you to take that shortcut, but it works. Okay, so D is also somewhat similar to that. It is 6 to the log base 6 of 4
A reminder of the buses that are running late this afternoon, bus 14 and bus 17. Those students please wait in the cafeteria till the replacement bus comes, bus 14 and bus 17. And a reminder that exams are tomorrow, so everyone get a good night's sleep and a good breakfast, and we will see you
Oh, I won't
all
be
at
sleeping.
7:45 a.m. sharp.
I will not sleep at all.
Okay,
Promise them that.
so whenever I'm taking a base to an exponent that has log of that same base, they cancel each other out. So 6 and log base 6 cancel each other out, gentlemen. 6 and log base 6 cancel, leaving just whatever was in my logarithm as my answer.
Okay,
Oh,
so those
why?
cancel out.
Oh, really?
Yeah, anytime I'm taking a number to the log with that same base, they cancel.
Okay.
So same.
This only works, oh my gosh, I'm gonna say this a million times. This only works if there's no number in front of my log or my natural log. We have to move that first into an exponent if it's present, and then we can do the cancellation.
No number in front of
If there's a number in front, you have to put it in the exponent before you cancel. Have an absolutely wonderful, minimally stressful day.
Also, that extra credit was due right now, right?
And that extra credit's due like right now.
Okay, because Becca was asking me and I told her right now, so I think it's probably come out.
I hope